All right, so let's go ahead and get started. I know that you guys are probably still working on this. Let's go ahead and talk about these. So on this first question for bell work, you had to solve for x. So does anybody want to unmute themselves and explain to me how to solve for x here?
Can I do it?
Yeah, go ahead.
So first you have to isolate the variable. So you have to minus 4y and put that on the other side.
Okay.
And then it's 2x equals 12 minus 4y. And then you must divide by 2 on each side. And then you should get x equals 6 minus 4y over 2.
If I simplified this part to get 6, I can also do 4y over 2, reduce the 4 and the 2. So what would you get actually?
2y.
There you go. Okay, so you should get x equals 6 minus 2y. Nice job. Okay, second one, you had to solve this one for y. Does anybody want to give this one a go? Yeah, you're the only one raising your hand and acting like you hear me. So yes, go ahead.
So you have to first you have to isolate the variable again,
Okay.
and then you have plus 9y, and then put it on each side. So then you get x plus 9 equals 3y.
Okay.
And then you have to divide by 3 for each side, and then you should get 3 plus x over 3 equals y.
Good. Thank you very much, Mitchell. So on both of those, isolating the variable, that is going to be something that's important here in this section. You are going to have to know mostly the second one, how to get y by itself, because that's going to be the format that we're looking for to graph. Right now, obviously, we have x over 3, but that's like having 1x over 3 or 1/3 x. That 1/3 would be like our slope in y equals mx plus b. And then that plus 3 in that problem would be like the y-intercept. So understanding how to solve a variable is going to be very important, especially solving for y, so that we can end up putting these on a graph. So is there any questions about solving for x or solving for y? All good there? Okay, so we talked a little bit about this yesterday about what a system of linear equations is, and that's when we have two or more equations that have an ordered pair in common. So you have a couple of answer options. You have exactly one solution, which is basically just one ordered pair, which is where they cross. That's the most common one that you're going to see. Naming the ordered pair as a solution. Okay, so that's always going to be an ordered pair xy. Okay, you do have the option of no solution, okay, which we did have yesterday, which is when they don't cross. So they're parallel lines and they don't ever cross. And then you also have the option of infinite solutions, which is when you have two lines that are right on top of each other. Okay, it's basically the same line for both equations that you graph. You graph one right on top of the other. So every single solution that's on line A would also be on line B because they're the same thing. Okay, so the most common one that you're going to see is the ordered pair, exactly one solution. But your other options are if they don't cross or if they're right on top of each other, then that's no solution or infinite solution. Okay, so what we're going to be looking at here is going to be graphing these systems of equations and trying to figure out what their ordered pair is. Okay, so we're going to start out. Okay, we're going to graph y equals negative 2x plus 3 and y equals x minus 5. And then if it has a solution, we're going to name it. Okay, so I'm going to do mine in color here so it's easy to see which is which. First of all, always make sure your lines are in y equals mx plus b so that they're really easy to graph. So y equals negative 2x plus 3. Okay, that means that plus 3 is going to be my y-intercept. So on my graph, I'm going to go to 3 and put my point right there.
This is Clark.
Yeah.
Jay's computer's not working. He's trying to restart it right now.
Okay. Thank you.
Yeah.
Okay, so starting at 3 for this one. Okay, now the slope is your number in front of x. Now, if it's just negative 2, that's like having negative 2 over 1. So from my y-intercept, I'm going to go down 2 and to the right 1. And for the sake of knowing that this is going to have to cross at a point that is in common, I'm going to put several ordered pairs on my graph just to make it as straight as possible. Okay, so I can see for sure where the line is running so I can see ordered pairs. It kind of keeps it from being crooked and looks like it intersects at a different point than what it actually does. Okay, so I put as many points as possible on these graphs, as many as I can fit. Okay. Now, we also have y equals x minus 5. Okay, so for this graph, we are starting at negative 5 because it's a minus 5. So on the y-axis, we're going to go to negative 5. And then my number in front of x, if there's not anything here, that's like a 1. And if there's no denominator, that's also a 1. So I'm going to go up 1 and to the right 1. And I'm going to do that several times until I can see where it crosses. Okay, we good so far? Okay, I'm going to pause this for just a second here. Hold on. Something is glitching on my end. I don't know if you can see what I'm seeing, but there's nothing happening. Hold on just 1 second.
It's not glitching whatsoever on our side of the game.
Okay, mine's glitching, so hang on. Okay, is everything good? Can you see I just wrote on the board right there?
Yeah.
Okay, I don't know what was happening over here. It just magically froze and was weird. Okay, so let's start. So let's review what happened here. So negative 2x plus 3 was this line. Okay, so we started at 3. We went down 1 to the right 2, or sorry, down 2, right 1, down 2, right 1, down 2, right 1, and so on. Okay, and then when we graphed our second line, we were at negative 5. We went up 1, right 1, over and over and over again until we could see what was happening. Okay, so we are going to approximate kind of where this intersects. So obviously it's not in a exact spot. Okay, so we're just going to approximate where this crosses, which is going to be about right here. Okay, so the ones that you guys see on the homework are going to be a little more exact, but I'm going to approximate this. I'm going to say that the x value is about 2.5, and I'm going to say that the y value is negative 2. Okay, so if it's close, okay, to a half or something like that, just approximate that. Okay, the bad thing about graphing these is it's not always going to be exact. Okay, so we're going to approximate as close as we can, okay, to the nearest half or to the nearest whole number and see what we come up with. Okay, and we always write our answer as an ordered pair, so the x value first and then the y. Okay, and then that's going to be the solution that we come up with. Is there any questions about graphing that or coming up with that answer? Okay. So we've got y equals negative 2x minus 5 and y equals negative 2x plus 3. Okay, so we're going to start graphing this with negative 5. Okay, so my blue line is going to be starting at negative 5. Now, if I cannot fit my slope on there going down 2 and to the right 1, I can also go up 2 and to the left 1. Up 2 and left 1 as many times as I need to. Okay, and then I can draw my line. Okay, then I'm going to graph my second line. Y equals negative 2x plus 3. Okay, so y equals negative 2x plus 3. I'm going to start at 3. Okay, my slope again is negative 2 over 1. Okay, so down 2 and right 1, down 2 and right 1. Okay, you should know by looking at the equation what's happening here. Okay, but it's more obvious whenever you graph them. Okay, these do not cross, and you should know they don't cross because their slopes are the exact same. Okay, which means that the lines are parallel to each other. So if they are not ever going to cross, then we're looking at one that has no solution. Is there any questions about finding one that has no solution? Yes. Okay, sounds good. Okay, Are we all good with ones that have no solution? Okay, so another one here. Okay, we have x minus y equals 2 and 3y plus 2x equals 9. So the first thing here that you need to understand is that these are not in the right format. I need them to look like y equals mx plus b. So if I'm looking at my first problem here, I'm trying to solve this like you did on the bell work. So I'm trying to get y by itself. So I'm going to do minus x on both sides. That's going to give me negative y equals 2 minus x. Okay. Now, I don't want negative y or negative 1y, so I'm going to divide everything by negative 1. That's going to change all the signs, so I'm going to get y equals negative 2 plus x. Okay. This is an equation that I can graph. Okay. Now, let's go ahead and graph that, and then we'll worry about the second equation. Okay. Starting out, the number that's by itself, that negative 2, that's going to be our y-intercept. Okay, my slope is my number in front of x, which in this case is a 1 or 1 over 1. So up 1 and to the right 1 as many times as I need to. Any questions about solving for that or how we graph that line? Okay, so now the second one we also have to solve. So 3y plus 2x equals 9. I need to get that so it just says y equals. So I'm going to subtract 2x off. And I'm going to have 3y equals 9 minus 2x. And then I'm going to divide everything by 3. So I get that y is equal to 3 minus 2x over 3, which is like 2/3 x. And this is what we're going to be putting on our graph. Okay. Now, if I start at 3, because that's the number that's by itself, that's my y-intercept. Now, remember for the slope, if it's minus 2/3, that's like negative 2 over positive 3. So I'm going to go down 2 and then right 3, down 2 and right 3. Okay, this one does cross at an actual point that they have in common, okay, which you can see right here. And your job is to tell me what that solution is. You can't just graph it and in there you have to actually tell me what their solution is. So if you name this ordered pair, okay, it's what their x is and what their y is. Okay, so x is 3, y is 1, and that would be your solution for that. Okay, any questions about naming the solution or putting it on the graph or any of the solving stuff?
Ms. Clark, I got a question.
Okay.
So if the slopes are reciprocal to each other, like 2x and then 1/2, would they still cross?
Yes, they would cross at some point. The only time that they don't cross is if they're exactly the same. Otherwise, they cross at some point.
Okay.
So like that second example we did right here where they were the exact same, that one was no solution. That's the only time that they won't cross. Now, sometimes you might have to draw a little bit of a bigger graph. They might not cross right in the middle of something that we can see. They might cross like past 10 or something like that, but that's not going to happen very often.
All right, thank you.
Okay. Any other questions about graphing? Okay, so just to recap what you're going to be looking at, okay, you're going to be graphing these lines. Okay, you're going to have 2 different lines that you're graphing and you're trying to see where they cross. Okay, again, your options were that you have exactly one solution. So what is the ordered pair where they cross? It's like what we did on the first one and the last one that we just did. Okay, where they don't cross at all, so they're parallel to each other. Those have the same slope. You wanted to add that to your notes there as a reminder that they have the same slope. They're no solution. Okay, if they're infinite solutions, that means they have the same line. Okay, so we didn't really do an example like that. Okay, but it's going to be obvious whenever you graph one line and then you go to graph the second one and see the exact same thing. Okay, so any questions about any of that?